Welcome at Python Intermediate series, Working with Lists. This course is part of a series where you learn what you should know beyond beginner level to become an intermediate Python programmer. In this part of the series, you will learn Python lists at intermediate level. To assess your programming skills, let me show you how we classify the beginner and intermediate levels. Beginners have to follow a recipe to write working code. They need examples and can only create small variations and experiments. They know the basic tools of the language, but have a limited overview of their full potential. Intermediates know the basic syntax and learn how to combine things. They know common solutions to specific problems. Basic knowledge is solidified and used for multiple purposes. This allows the former beginner to expand possibilities and design more effective code. This course enhances the process to get from beginner to intermediate. Going from copy and paste to creating code yourself is one of the most important steps. Beginners become programmers when they start deciding how to solve problems. The more tools and their possibilities are known to them, the better this works. Developers who especially benefit from this course are beginning programmers with roughly 6 months Python experience who want to take their coding skills to the next level. Or developers who bring experience from another programming language and want to learn how to work with lists in Python. Or self-taught Python developers who want to improve their list skills by learning best practices. After this course, you are able to make better decisions when to use one of the 4 built-in container types by seeing their specific features. You work with lists more efficiently by using Python-specific language features like unpacking, slicing, and comprehensions. You can optimize your existing code after learning that Python offers many built-in list operations. The chapters in this course are: what is a container? Lists, tuples, dictionaries, sets, common operations, slicing, and comprehensions. For this course, you need the following things. You know basic concepts of Python or any other language like variables, lists, and loops. You have Python installed and can execute programs. Why this course? Learning programming can be done in many ways. Often developers learn by doing. They copy code from online videos, blog posts, or Stack Overflow. And when you start your programming career, this method is absolutely fine and often leads to success in the short term. Small tasks are solved quickly, but unexperienced programmers do not always recognize that their code gets needlessly complex and perhaps is even prone to errors. Often there are more efficient ways to do something. Sometimes the solution to your problem is already built into Python. Once you are aware of these possibilities, you can take efficient shortcuts to get to the goal. In this course, not only will you learn various tools that are available to you, but also why and when to apply them in your code. I mean, what good is a hammer if you do not think about a nail? I will explain common list challenges, and with the help of many examples and exercises, you will learn how to solve them with the help of built-in list types and functions. Here you see such an exercise. Notice it has a title and a suggested file name. I recommend that you create a new Python file for each exercise That way, you can easily find your code back in a week, month, or year from now. Exercises in this course will also show some pre-written code. As you can see, some of the code is covered by boxes. It is your task to fill out the missing code. Finally, you will see the solution so you can compare it to your code. I know you want to expand your Python knowledge, and together we will achieve this, step by step. I will be there to guide you through this process. By the way, who am I? My name is Luc van den Ouweland and I am a software engineer and trainer. I teach beginners how to create their first programs and I help professionals to understand Python better. I have worked for many companies including Philips and Microsoft. During my many years of experience, I have always combined software engineering with training on the job. And now you can benefit from this as well. So let's start with the first chapter of the course. But before we do, I wish you good luck. Enjoy the course. What is a container and which one should you use? In this chapter you learn that Python has 4 built-in containers and get an introduction into their unique properties. Let's start by answering the question, what is a container? Look at this list. It has 3 names. And look at this coordinate. It has 2 values. Finally, look at this phone book. It links names to phone numbers. What do all these have in common? Each example on the screen is a list of things that are stored in a container. I bet you have already worked with lists, tuples, and dictionaries. These are objects that can contain other objects. They are collectively known as containers. Unfortunately, there is some confusion in the naming here. Containers are also known as sequences, iterables, compounds, and to add to the confusion, containers are sometimes also called lists. In this course, we stick to the name container as the collective definition for list types like lists, tuples, and dictionaries. Here they are again. And in this course, you will learn a 4th container type: sets. These 4 containers are built in Python and can be used without having to import any module. If you wonder where the name container comes from, just think of the list types you have already used in Python. Look at this names list. It contains 3 items. Now look at this phone book dictionary. It contains 2 items. Both the list and the dictionary contain items. This already answers one question you might have. Why is it called a container? Answer: because containers are objects that can contain other objects. This might sound obvious to you, but I had to look it up because English is not my native language and I never made the connection in my head. Now that we know what a container is, let's have a look at its properties. Each object in a container is called an element. Containers allow us to loop over its elements. When a container allows to loop over its elements, we say the container is iterable. All containers in this course are iterable. Looping over the items is called iterating or iterate. Some containers in this course also allow accessing specific elements. For example, accessing the second element directly without having to go through the list from the top. Most containers allow you to add and remove elements, and some containers are read-only. The 4 container types in this course all have unique properties and different applications. Let me show the 4 built-in containers again. One of the goals of this course is that you can look at a specific requirement in your code and know what kind of container to use. You will learn this with many examples and exercises. But before we start with the first container type, I will give you an idea of what we are going to do with each container type. We will start with lists. Think about to-do lists. Adding and removing items is allowed. Tuples are immutable. They are used for creating data structures like coordinates. X and Y belong together, and once a tuple is created, changing individual values is not allowed. Dictionaries map keys to values. Think about a phone book. An important feature of dictionaries is looking up values. Finally, we look at sets. Perhaps you remember these from math class. Sets allow you to find which elements appear in other collections. Now that you know what a container is and have a basic idea of the purposes of the built-in container types, let's start with the first type. Lists. In this chapter, you will learn the first container type, lists. After this chapter, you know how to create and iterate lists. You can access elements and mutate lists. You have also learned how to sort and reverse lists and how to apply common queries like min, max, count, and index. I'll start with an example that most beginning Python programmers have already seen. I'll create a list and iterate it. A list in Python is created with square brackets. You are looking at an empty list. At this point, you can already print the empty list like this. Python shows the empty list. I'll add some names to the list. As you can see, elements in a list are comma separated. I'll execute the code. Notice that I used double quotes to define the strings in the list. But Python represents strings with single quotes. In Python, single-quoted strings and double-quoted strings are the same things. There is no recommendation whether to use single or double quotes, and in this course you will see me using double quotes to define strings. Let me loop through the list elements. That works as expected. I'll print the total number of names. The length function returned the length of the list. Let me format this a bit nicer by using an f-string. Consider this a warming up example. Soon you will see more exciting list features. But first, let's practice the basics. Time to practice. Create a names list, iterate and count the items. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let's do another one. Create a to-do list, count and iterate it. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen how to iterate a list in Python. But what if access is needed to certain elements in the list? Python has many ways to access elements in a list, and you will start with the most common one. Accessing elements by index. Let me show you how this works. You probably know what happens when I execute the code. The first element from the list is accessed by its index 0. What if I want to access the second element? No surprises here. By the way, did you know that indexes are also known as subscripts? Getting an element by index is called subscription. In a later chapter, you will also learn about slices, which return ranges of elements. For now, let me show you some tricks you can do with subscription. What if the last element from the list is needed? In most programming languages, you could do something like this. This will get the element at the last index of the list. That works as expected, but Python has a much more clever way to get the last element of a list. It is called negative indexing, and it looks like this. Both methods returned the last element of the list. This also works for the second to last item. You see the pattern here. When the index is negative, Python adds the length of the list to it. Time to practice. Get the first, third, second to last, and last element from a list of weekdays. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Did you know that a string is also a container object? It contains a list of characters, and the characters can be accessed with subscription. What do you think is the output of this code? Feel free to pause the video and try it out. Yes, subscription also works with strings. Lists are mutable. That means elements can be added and removed after the list was created. Adding elements at the end of a list is called appending. Let me type two methods you probably have seen before. Here is a list with names Vera and Chuck. I'll add another name to it. Let's see if Dave is added to the list. That works. Now let's remove someone from the list. Chuck was removed from the list. Be careful not to remove a name that does not exist. What happens when I remove Chuck again? Python tells us X is not in the list, and we should really check if something is in the list before removing it. But we'll deal with that in a later chapter. First, let me show you how to insert an element at a certain index. I'll insert the name Joanna between Vera and Dave. Look at the name Joanna. It was inserted at index 1. Time to practice. Append, remove and insert elements in a list. Fill out the missing code. Pause the video and resume when you are done. And here is the solution. You have used remove to remove elements by their values from the list. It is also possible to remove an element at a certain index. Look at this list box. The user has selected the third item. We are not interested in the value of the selected item. The only thing we know is that we want to delete the third element. This can be done with the pop function. Let me show you. Here is the list that feeds the list box. Now the item at index 2 needs to be deleted. Let's have a look at the updated list. That works. Dave is gone. You might know that there is another way to delete elements at a certain index, and that is with the del statement. But there is a reason why I use pop. Let's say you want to inform the user that Dave is deleted. How would you do that? I would have to store the element in a temporary variable like this. And then use the variable after deleting. And this works, but the pop function allows us to do this much nicer. Pop removes an item and returns the removed item. We can use it like this. I'll comment out line 3. And assign the return value of the pop function to name to delete. Very nice. There is no need to access the element before deleting anymore, and you can safely delete line 3. You have seen that lists can be created with some elements in it. You have also seen that lists can be changed with methods like append, insert, remove and pop. We say that lists are mutable. Once the list is updated, the order of elements is persistent. That means that each time Python loops through them, the order is the same. Until you mutate the list again. And there are more ways to manipulate lists. Python has 2 common ways to sort lists. Let me show you. Calling the sort method on the list changes the list. You cannot undo the sorting. If you want to keep the original list, you can use the sorting function like this. You see that the sorted function returned a new sorted list. And let me demonstrate that the unsorted numbers list is not changed. Whenever you need to change the original list, you can use the sort method. And if the original list needs to stay as it is, use the sorted function that returns a new sorted list. Something similar happens when lists are reversed, but with a small difference. Let me show you. That works as expected. The list is reversed. But what if the original list needs to stay as it is? For this, you can use the reversed function like this. The reversed function returned a new list. The unreversed numbers list is not changed. There is, however, one difference compared to sorting. Let me show you the list types of unreversed numbers and reversed numbers. As you see, the reversed function did not return a list. It returns an iterator. So what is an iterator? Look at this list of 4 numbers. When a loop is used to traverse through the list elements, an iterator is used. The iterator is an object that points to a single element in the list. Typically, it starts at the first element in the list. Each time a new element is requested by the loop, the iterator is moved to the next element in the list. The iterator continues to move to the next element until the end of the list is reached. So what is the difference between the reversed method and the reverse function? Look at the list of 4 numbers. An iterator would go from beginning to end. If the reversed method is called, the list is reversed and the iterator would still go from beginning to end. But when the reverse function is used, the list stays the same, but the function returns a reversed iterator that would go from the list from the end to beginning. So what is the impact of this? You already saw that you can loop through an iterator. But there is one thing that is not allowed with an iterator, and that is subscription. When I try to print the first item of the reversed list, an error will occur. As you see, the iterator is not subscriptable and you cannot get its elements by index. The reverse method will change the original list, and the reversed function will return an iterator that allows you to iterate with a for loop. You just saw how to sort and reverse lists with numbers. You can do the same with lists that contain strings. Reversing will reverse the list of strings. But how will Python sort a list with strings? Why don't you try it out? Sort a list of names. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. By the way, did you know that lists in Python are heterogeneous? That means that its elements do not need to be of the same type. Until now, you have put numbers or strings in a list. But it is perfectly okay to mix numbers, strings, and even your own custom objects in the same list. You probably won't need this very often, but if you do, Python allows it. Let me show you some more common tasks to perform with lists. I'll create a list with names. Notice that Chuck is in the list twice. Let's count the occurrences of Chuck. Chuck is in the list 2 times. I can check the index of the first occurrence of Chuck in the list. Python shows the index of the first occurrence of Chuck in the list. The index method will raise an error if the element is not in the list. Let me show you. A value error occurs. You could check the count before using the index method, but in a later chapter I show you better ways to check if an element is in a list. First, let me show you 2 very helpful functions in Python. For this, I create a list with numbers. That works as expected. Let's exercise what you just learned. Create a numbers list, find the largest number and count how many times it occurs in the list. Then show the index of the first occurrence of that largest number. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen an introduction to lists. You learned that lists are mutable and elements can be accessed by index. Finally, you saw how to sort and reverse a list and how to count elements. Now that you know how lists work, we can explore a very important variation on it. In the next chapter, you will learn tuples. What is this data type called tuple? What are its common use cases? After this chapter, you have learned a powerful container type that has unique features like immutability and tuple unpacking. You have seen features like assigning multiple variables and swap variables. Let's start with the question: what is a tuple? In the previous chapter, you saw how to create a list with numbers. Here is a list with the numbers 1, 2, 3, and 4. Notice the square brackets. Here is a second list with the numbers 1, 2, 3, and 4. This time as a tuple. Notice the round brackets. Now you know what a tuple looks like. But what is a tuple good for? For a long time, I considered tuples just a variation on a list, but with the difference that a list is mutable and a tuple is immutable. And technically, this is true, but it turns out that tuples are meant to be used in different situations and for different purposes than lists. Let me show you some examples. Let me start with something you probably have seen before. How can the function return x and y? The return statement can only return a single value. This is a good example where multiple variables can be packed into a tuple like this. As you can see, point is a tuple that contains x and y. Since a tuple is subscriptable, you can access its elements by index. Notice that I assume there are two elements in the point tuple. This shows why it is important that a tuple is immutable. Let me demonstrate immutability by trying to remove an element from the tuple. Look at the error. Removing or adding or changing elements in a tuple is not allowed. I can safely assume that the tuple was not changed between the time it was created and used. Notice that I used round brackets when creating the tuple. Python also allows to omit the brackets like this. The output still shows a tuple. In most cases, you can choose to use brackets or omit them. Later, I'll show some edge cases where brackets are required. Let me show you another tuple use case. Look at function draw. It takes x and y and prints them. Other function also takes x and y and calls function draw with them. Third function also takes x and y and calls function other function with them. I'll call third function. A construct like this is very common. X and y need to be passed around in a program until they are used. But what if the draw function needs more info, like the point color? I would have to add it to all the function parameters. This works, but you see how this is not very convenient. A tuple can help us to keep the data structured and pass all the point information as a single variable. I'll start by packing the data in a tuple by adding round brackets. Notice that we must use round brackets to define the tuple to prevent confusion with the brackets for the function call. Now I replace all variables with a single tuple variable. The only thing I need to do now is get the individual values from the point tuple. Each function now passes a tuple to the next one. If points need more information in the future, you only have to add it to the tuple here. The function parameters can all stay as they are. Did you notice in the last example that the tuple contained two numbers and one string? When containers contain multiple data types, we say they are heterogeneous. Since Python is a dynamic language, all containers are heterogeneous. But when you look at the application of lists and tuples, you can conclude that tuples usually have multiple data types, and lists usually contain elements that have the same data type. But be aware that Python will not enforce this in any way. Let me give you another example where lists and tuples are combined. Look at both lists. I'd like to show the data like this. This is one of the problems that is very familiar to data scientists. The x and y values are in two lists and Python does not know they are related. This problem is solved by making a single list where each element is a tuple of x and y. In a later chapter, you learn how Python can merge both lists. But in this chapter, I create the list manually. It is now very easy to show a list of points. That works. Let me get rid of the two separate lists. Time to practice. Create a list of tuples. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Until now, each element of the tuple was accessed with subscription. But Python has a feature that makes working with tuples even nicer. It is called tuple unpacking. Let me show you how it works. At this moment, p is the loop variable and contains a point tuple. I can unpack the tuple into variables x and y like this. And now I can use variables x and y in the f string. Look at the output. That works. The technique you are looking at is called tuple unpacking. Notice that the set of variables on the left side matches the length of the tuple. Time to practice. Tuple unpacking. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let me show you some interesting uses for tuples and tuple unpacking. For one of my courses, I needed to define the three variables you see on the screen. Let me print them. No surprises here. But to keep everything on one slide, I needed to compact the code. And you can do it with tuples and tuple unpacking. Let me rewrite the code. It works. What is happening here? This code creates a tuple, and this code before the equal sign unpacks the tuple in 3 variables. This is a compact way to define multiple variables in a single line of code. Time to practice. Assigning multiple variables. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. The next Python feature is very interesting to anyone who had to swap 2 variables before. I create 2 variables and print them. A is 10 and B is 20. Sometimes you need to swap variable values. In most languages, you can do something like this. And that works. But I had to create the temporary variable to make it work. Maybe tuples can help us here. Let me try to swap the variable values back with tuples. Yes, the values are swapped back. You probably can already see what is happening here. Variables b and a are packed into a tuple, and the tuple is unpacked in variables a and b. Swapping variables can be done with more than 2 variables. Look at these 3 variables. What if all the values need to be shifted like this? You can do this too with tuples. Let's practice swapping variables. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen that tuples can be defined with brackets or without brackets. I especially like the latter variation in code like this. Look at the code. A tuple is used to make a loop with 3 numbers. Let's practice this. Create a countdown. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. By the way, if you ever need a tuple with a single element, just define the element followed by a comma. That will do the trick. You have seen that a tuple groups variables that belong together. You have seen that a tuple is immutable. Tuples can be used as arguments to pass to functions. And you have seen that you can get data out of tuples with tuple unpacking. You have learned how to work with tuples. In the next chapter, you will learn about dictionaries and their unique features compared to lists and tuples. What is one of the most common things to do with containers? In this chapter, you will learn to create dictionaries and explore their main purpose, which is to look up values. You also learn how to iterate a dictionary, change a dictionary, and perform safe lookups with getValue or default. In the previous chapter, you saw that tuples group data that belongs together. Data can be accessed with subscription. You also saw tuple unpacking. For this, the length of the tuple must match the amount of variables you unpack to. You also have to know the order of the elements in the tuple. Now let me show another container type that stores a group of objects. It is called a dictionary, and just like tuples, it has some unique features. The most important feature is the lookup mechanism. What does that mean? Let me show you. This is a dictionary with 3 elements. A dictionary is defined with curly braces. Dictionaries use a colon to assign a value to a key. At this point, I can look up values with key subscription like this. Notice a lookup is done by key, not an index. I'll execute the code. As you can see, the salary for Vera was looked up and printed. Time to practice. Create a dictionary. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Dictionaries are also known as map, hash, hash map, but they all do the same thing. They are a key value store. You just saw a homogeneous dictionary. All keys were of the same type and all values were of the same type. In Python, you do not have to specify types for dictionary keys and values, and this makes it very easy to use dictionaries for heterogeneous data. Here is an example. If you would go to Amazon and click around a bit, you will notice that the browser keeps adding data to the website address. This data is called a query string. This query string has 2 elements, ID and refer. Notice each element has a key and value. A query string is a dictionary. Also notice that the values have different data types, int and string. Can you create this dictionary and show its elements? Let's practice a query string dictionary. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen that dictionary values can have different data types. The keys can also have different data types as long as they are hashable. What does that mean? Objects in Python have a hash value. This value is generated from immutable data in the object and needs to stay the same over the object's lifetime. If you want to know more about this, I encourage you to watch one of my other courses called Python Objects with Special Methods. In that course, I explain the internals of Python objects, including hashing. In this course, we will stick to strings to use as keys, which is fine for most use cases. Lists and tuples can be iterated. Although dictionaries are commonly used for lookup purposes, you can also loop through them. Let me show you. Here is the example with the salaries again. I loop through the dictionary. What do you think is printed? As you can see, the dictionary keys are printed. To print the dictionary values, you have a couple of options. That works. Here is another way to get the dictionary values. You can even get both the key and the value by using the items method. Both the key and value are printed. Do you recognize this pattern? The items method returns a list of tuples. Each tuple contains a key and value and is unpacked in K and V. I use looping through dictionaries mostly for debugging purposes. For example, if a dictionary was passed to a function and I want to see what is in it. Dictionaries are mutable. That means you can add, remove, and change items. Adding items to an existing dictionary is done by setting a new key like this. Samantha is added to the dictionary. What happens if you set an existing key? The existing dictionary element is overwritten. Deleting an element is similar to deleting an element in a list. I'll remove Chuck from the dictionary. Chuck is removed from the dictionary. The pop method returns the value of the deleted item. Now you have seen how to add, change, and delete dictionary items. Time to practice. Change a dictionary. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. What happens if you need a value but it is not certain that the value is in the dictionary? Look at this dictionary. It has keys ID, cat ID, and browser. Let me print the browser value. That works. But the query string we get from the system is not guaranteed to have this value. I remove it from the query string and run the code again. The program crashes with a key error. Python cannot look up key browser. In a later chapter, you learn how to check if elements are in containers, but dictionaries provide another way to deal with this problem. Python can return none if the value does not exist. the key did not exist and Python returned none. The get method also takes a default value argument. And that is how you can get a default value if the key does not exist. Time to practice default values. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen how to perform common dictionary operations. By finishing this chapter, you have seen your third container type, dictionaries. In the next chapter, you will see the last built-in container type, sets. Why is the set always the last container type that is shown? Don't be fooled by the order of the built-in container types in this course. Sets have powerful features, and in this chapter you will learn their purposes. You learn to calculate new sets by using operators and know how to check for membership by comparing sets. The set is the fourth container type you will learn in this course. A set has unique features. They are: no duplicate elements allowed, elements can be added or removed but not changed, subscription is not supported. Let me start by showing you what a set looks like. You are looking at a set of names. What can you do with a set? Does it allow iteration? It does. But look at the order. It is different from the definition. And that is the first thing to know about sets. They are unordered. So what happens if you access its first element? An error occurs. And that makes sense. If the set is unordered, getting an element at a certain index does not make sense. If sets are not subscriptable, changing elements is also impossible. The only change a set allows is deleting and adding elements. That works. Paul is removed and Mel is added. What happens if an existing name is added to the set? Interesting. George only appears once in the set. Sets do not have duplicate elements. You just saw that a set does not have duplicates. This is a feature that is used often when the data comes from other sources and duplicates need to be removed. I'll show more about that later, but first we need to answer the question. If elements of sets cannot be accessed and changed, what is the use for a set? Look at these two sets. Perhaps you remember from math class that sets can be used to check what elements in one set are a member of another set. And where would you use this in a computer program? Look at this files list. It contains 4 files. An update to the system occurs. Here is file salary.py. The system needs to know if the file was already in the list or not. This is where sets can help you. The differences between sets can be calculated with various set operations. This is what the file manager of your computer does all the time. An update from the file system comes in, and the file manager has to figure out what files are new, deleted, or updated. Differences between sets can be calculated with set operations. Python also supports set operations. We will look at the following operations: union, intersection, difference, and symmetric difference. So what do these operations do? I'll start with union. A union operation takes two sets and returns elements of both sets, where duplicates are ignored. Here is an example. Chuck is in both team sets. I create a union of both sets, and Chuck should only appear once in the new team. Chuck only appears once in the new team. Look at the pipe operator. This performs a union between two sets. Time to practice set union. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Intersection. Elements must be in both sets. Duplicates are ignored. Look at these two words. If you want to create a crossword puzzle from them, you have to find out their shared characters. It turns out you can combine the words like this. The characters N and W are shared. They intersect. But why figure this out ourselves? Let's use sets for this. I will use intersections to find the shared characters. The shared characters are shown. Time to practice intersection. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. In the last exercise, you saw that an empty set is printed like this. But you might have expected this. But curly braces are already used for dictionaries. So to create and print an empty set, use set with round brackets. Now we move to one of my favorite set operations, which is difference. The reason that I like this one so much is because I use it often. So what does it do? Let's say that you have a shop, and in week 1 you offer these products. In week 2 you sell the following products. Look at the difference. Parmesan and tagliatelle are the new products. I'll use a set difference to calculate the new products. The difference, which are the new products, are shown. It's time to practice. In the following exercise, you are going to combine intersection and difference. Let's return to the example of the file manager. Look at the first list. It contains 4 files. An update comes in with a new list. You need to figure out 3 things. Deleted files, files that stay in the list, their date, time or file size might be changed, and the files that are new in the list. To solve this problem, you will use set intersection and set difference operations. Practice set updates. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let's have a look at one more operation. A symmetric difference calculates all elements from either set that are not in both sets. You will find this often in probability studies. Let me give you an example. Leo and Hans work at a flex office with only 2 desks. Everyone can take the first 3 desks available. As you can see, today both desks are occupied and everyone is working very hard. Leo works at the office on Mondays, Tuesdays and Wednesdays. Hans works at the office on Wednesdays, Thursdays and Fridays. Lottie arrives at the office. No desk today. Lottie wants to prevent coming to the office when all desks are occupied. She decides to use set symmetric difference to calculate the days where at least one desk is free. Let me show you. Lottie starts by creating 2 sets with the days that Leo and Hans are at the office. Lottie wants to exclude all days where both Leo and Hans are at the office. Using symmetric difference should exclude the Wednesday. Look at the output. Wednesday is not in the result. Lottie is sure that when she comes to the office on one of these days, she will have a desk to sit at. Until now, you have seen set operations that return new sets. But what if you need to compare sets? Perhaps you remember this from math class. Look at set A and set B. All elements from A are also in set B. We say set A is a subset of B. And Python has an operator for this too. Let me show you. Meet Karen. Karen has time to go to a yoga school 2 nights a week. She is available on Mondays and Thursdays. There are 3 yoga schools in her neighborhood and she asks when they offer yoga classes. Here you see the days yoga classes are offered at each school. You need to figure out what school fits Karen's schedule best. Do we really have to figure this out ourselves? Of course not. We have Python. Let's use subsets and supersets to find out a good match. You start by defining a set with your available days. You got the yoga programs from the studios in your town and also store them in sets. Now I check if the available days are a subset of the other sets. Look at the result. It seems that Say Ganesh offers a match for your schedule. This is because the available days is a subset of the Say Ganesh set. But now the Yoga Studio strikes Tuesdays of its program. I execute the code again. All results are false now. Although the available for yoga set is a perfect match for the Yoga Studio, it is not a subset. To check if a set is a subset or equal to the other set, add an equal sign like this. And now it gives the expected result again. You saw how to check if a set is a subset of another set. You can probably now guess how to check if a set is a superset of another set. If the Yoga Studios would like to check if they have an offer for you, they can do this. The results should be the same. Only the Say Ganesh check should return true. And that is how checking for subsets and supersets work. Time to practice subset and superset. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. We have used operators to perform set operations. But if you prefer, you can also use set functions to perform set operations. If you prefer that, you can find more information about them in the Python documentation. You have seen how sets work in Python. You learned their purpose and saw how to calculate with them. You also have seen how to compare sets. In the next chapter, you will see common container operations. What can you do with the 4 container types you have learned so far? You are now ready to learn operations that can be applied to one or more of the containers. You learn alternative ways to create containers. You will check the presence of elements and perform Boolean evaluation. You learn to concatenate, zip, and enumerate containers. You have seen the 4 built-in container types and their unique features. In this chapter, you are going to learn common container operations. The operations you are going to see all have different use cases. Some work on all containers, some on specific containers, and some use a combination of container types. Let's start with looking at alternative ways to create containers. You have seen how to create a list with square brackets, tuples with round brackets, dictionaries with curly brackets with key value pairs in them, and sets with curly brackets with just values in them. But containers also have a constructor. Let me show you how to use container constructors to create empty containers. I'll create an empty list, empty tuple, empty dictionary, and empty set. I know these look like built-in functions, but they are not. Each call is a call to a container class constructor. I'll print the variables and execute the code. As you can see, the resulting containers are empty. Empty curly braces indicate a dictionary. Empty sets are indicated like this. Container constructors take other containers as parameters. A common example is to convert an immutable tuple to a mutable list like this. L1 is a list with the elements from the tuple. Here are more examples where a container type takes another container as input. You see that containers with elements can be used to create other containers. But what about dictionaries? A dictionary element is a mapping from key to value. But the list is a flat list of numbers without a key. So the list has to define each key-value pair as a tuple. This works. In a later chapter, you will learn Comprehensions, which adds a lot of options when converting containers. Let me show you another way to create a list. This time we use a string as the source for a list. Look at this comma-separated string. All elements are separated by a comma. How do we put these elements in a list? Let me show you. The variable you see is a string. Remember that you can check variable types with the type function. Python shows us that the variable is a string. Now I split the string on commas. The split method returned a list. I chose a comma as separator, but you can use any separator character of choice. Time to practice. Deserialize strings. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. What you just saw is called deserialization. Deserialization is the process to translate data from, for example, a text file on the hard drive or data that comes from a network, to objects. It is also possible to do the reverse, which is called serialization. Here is the code needed to serialize the names list to a comma-separated string. If you want to try this out yourself, pause the video and resume when you're done. In an earlier chapter, you saw how to count specific elements in a list. The result is an integer. Tuples also support the count method. If count is greater than 0, the element is in the list. Dictionaries and sets do not have a count method. To check the presence of elements, Python has a more generic way that works with all containers. Let me show you. I create a list of names. Chuck is in the names list and the in operation returned true. Dora is not in the names list and the in operation returned false. To invert the result, Python provides the not operator. Dora is not in the list, so the not in operator should also return true. And it does. The in keyword works with all built-in containers. The in keyword is a generic way to check the presence of elements in containers. Time to practice. Check the presence of elements in containers. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have just learned how to check if certain elements are in containers with the in operator. You will now learn two built-in functions that check if the collection of elements is true or false. What does that mean? I create a list with booleans. There are 4 servers and the booleans tell us the online status. How would you create a function that checks if all servers are online? You could write something generic like this. Let's test if all servers are online. The result is false because not all servers are online. A function like this is built into Python and it is called all. The result of the all function is the same result of our custom function. It is also possible to check if at least one of the servers is online with the any function. This should return true because 2 of the servers are online. and it does. The all and any functions check for truth values. This is not limited to booleans. For example, the values 0 and 1 also have a boolean value. Can you guess the output? The all and any functions work like Boolean operators on the list of numbers. Let's practice these functions. Time to practice list elements truth. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Did you know you can also concatenate lists with the plus operator? The result of the concatenation is a new list. Concatenation also works with tuples. You can try that out yourself by changing the square brackets into round brackets. Pause the video and resume when you're done. Perhaps you also tried concatenating lists and tuples and got an error. Mixing containers with the plus operator is not allowed. The next function you will learn is the zip function. This is a popular function used by data analysts when data comes from different sources. Let me show you how it works. In the Tuples chapter, I showed you this code. X values and Y values are stored in two lists and are not connected. The solution was to create a list of tuples where each tuple contains an X and Y value. Python has a built-in function that can do this for us. Let's inspect points. The result of the zip function is a zip object. This is not a new list, but an iterator that can be iterated with a for loop. That works. The zip function can take any number of lists as input. And that is how Python can zip lists. Time to practice zipping lists. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let's do one more. Zip 3 lists. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. By now you understand that containers are very powerful tools in Python. And we only have just started mixing up things. After this chapter, you will see container operations that are not even available in some other modern programming languages. But before we end this chapter, I'd like to show you a last nice trick. Here is a list of 3 names. Let me ask you a question. How would you get an output like this? The answer is enumeration. To print a list of names prefixed with a number, I have to do something like this. This will work in pretty much every programming language. This is the result I wanted. But I needed to increment the index variable manually. Python offers a more elegant solution for this. The enumerate function created a list of tuples where each tuple has an index and value from the names list. Each tuple was unpacked in variables index and name and used in the print statement. Time to practice. Create a choice menu. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Your toolbox is growing. Until now you have seen how to perform operations on containers. But what if you need only a certain range of a container? You will see how that works in the next chapter. Slicing. What if a list is long and you only need a part of it? How can you cut a list in pieces to process it partially? This is done with slicing. You learn slicing arbitrary ranges and algorithms like head, tail, init and last. In the previous chapter, you saw operations that were applied to lists, tuples, dictionaries and sets. You learned that elements in lists and tuples can be accessed by subscription with an index. Dictionaries also support subscription, but with a key. Sets do not support subscription. Lists and tuples also support slicing. So what is slicing? We'll start with slicing an arbitrary range of elements. Look at this image. It visualizes a list with 5 items. You already know how to get the first item of a list. You get the element at index 0. This technique is called indexing or subscription. A single index returns a single element. For example, the second element is found at index 1. But what if you want a range of elements? Python can do this with a technique called slicing. Let me show you how this works. I create a names list with 5 elements. Now I create and print a list with elements from index 1 to index 3. As you can see, Team 1 is a list of 2 elements. Index 3 was excluded of the resulting list. Slice operations return new lists. The original names list was not changed. The names list still contains all 5 elements. Slicing allows for many interesting ways to get partial lists. Look at the last two lines. When the slice starts with 0, the 0 can be omitted. The slice got two elements from the beginning of the list. Getting elements from the end of the list works in a similar way. The slice includes index 3 and all elements following it. Time to practice slicing lists. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Do you remember using a negative index to get elements at the end of a list? Negative indexes can be used in slices too. Look at this example. The slice starts at the beginning of the list and ends at the second to last element. The result is the names list minus the last element. Let me give you another exercise where you will combine subscription and slicing. Time to practice special list parts. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let me show you the result of the exercise. The first operation returned the first element as a single value. The second operation returned a list with all elements except the first one. The third operation returned a list with all elements except the last one. The last operation returned the last element as a single value. These four operations are very common when working with lists. They even have their own names. They are called head, tail, init, and last. And you just wrote the code to get these values. Well done! Operations like these are used often when dealing with streams of data. Let me demonstrate this with the head and tail operation. Here is a list of joystick actions. Iterating the list at this moment results in 4 repetitions. But while iterating the list, the joystick might add more events to the list. This would mess up the iteration. I want to print each joystick event and only stop when the list is empty. This can be done with a while loop and the combination of the head and tail operations. The joystick events are printed until the list is empty. Even if joystick events are added during the while loop, this code keeps working. Head and tail are operations you will find often when dealing with streams of data. Time to combine a few things. A string is a list of characters, and slicing works here too. Let me show you a common thing to do: buffering strings. Look at this message. How would you print the first 4 characters of this message? That's right, just use slicing. Chunks of characters can be used as packages to send through networks, for example. Let me give you a challenge. Given this message, how can you get this output with a while loop and list slicing? Time to practice. Buffer text. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Before we finish up this chapter, I'd like to show you one more slicing option. Notice that the slice has a start index and end index. Now I'll add a third number to the slice. Look at the difference. The third number is a slice step. Step 2 means that the slice skips every other element. Time to practice slice step. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You have seen how to get parts of lists with slicing. There is one tool left to show, and it is the most powerful one you will see in this course. It has a strange name, but will improve your Python skills. In the next chapter, you will learn Comprehensions. Containers can be transformed to other containers. And Python has a very nice technique to do this. With Comprehensions, you can map and filter elements in a container. You learn how to convert lists to dictionaries and how generator comprehensions allow us to perform efficient list queries. I was looking forward to this chapter. Comprehensions are my favorite tool in Python and I use them all the time. You are going to learn 3 comprehension types: list comprehensions, dictionary comprehensions, and generator comprehensions. A comprehension is a way to make a list based on another list. This is a very common thing to do. Let me give you an example. Here is a list of 5 numbers. I want to create a new list where each number is doubled. Here is the new list. Notice the old list and the new list both have 5 elements. Since you have already worked with lists, you have all the knowledge to implement an algorithm that should work in pretty much any programming language. Let me show you. Now I create a second list and append the doubled numbers to it. Yes, that looks about right. I bet you have written code like this many times. Now let me show you how to do this in a much more compact way by using list comprehensions. I'll create a new list with tripled numbers. The numbers are tripled. I'll put the code to double and to triple side by side. Take a moment to look at it. The first thing you notice is that both variations have a for loop. Both contain an expression that multiplies numbers. A big difference is that the code on the left needed an empty list to start with, and then append each element. Where the comprehension is an expression that returns a new list. The process you just saw is called mapping. Elements of one list are processed and returned in a new list. After this operation, both lists usually have the same length. Mapping is a very common thing to do in any programming language, and with comprehensions, Python can do it very elegantly. So let's practice your first comprehensions. Time to practice list comprehensions. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Did you know that you can also use list comprehensions to create a copy of a list? Look at this code. The comprehension returns each element without changing it. This code will create a list copy. Notice that the elements are shared in both the original list and the copy. Comprehensions have many more applications. Let me show you another example. Here is a list of name tuples. I use a list comprehension to create a new list where each element is a string with the full name. Very nice. Look at the comprehension. It uses an F string to combine the first and second element of each tuple. This code can even be improved by using tuple unpacking. The comprehension transformed a list of tuples to a list of strings. The mapping you just saw created a new list where each element is of a different data type. This shows that comprehensions can also be used to transform a list of one data type into a list of another data type. In this case, a list of tuples to a list of strings. Time to practice. Compose file names. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Now we look at a second application for comprehensions: filtering. Look at this list of artists. You want to filter on certain bands. You type a search text, and the list is filtered. We can use list comprehensions for this too. Notice that after the search, the length of the lists are different. Let me show you how to do this in the code. Here is the list with band names. The goal is to filter on some text. First, I'll create a comprehension that returns a copy of the bands list and print it. The result is the same list of bands. Now I add a filter to the comprehension. This is done with the if keyword. The band list is filtered. Look at the if clause in the comprehension. It tests if the filtered text is in loop variable b. I know comprehensions take some time to get used to. So I'll show you one more and then you can practice them. This time I create a list of numbers and create a comprehension to filter the list. Numbers greater than 10 were returned. Time to practice filtering lists. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. You already start to see that list comprehensions are very powerful. But perhaps you are wondering why they are called that way. For me, as a non-English speaker, the word comprehension was a bit confusing because to comprehend means to understand. What does list transforming have to do with understanding? So I started searching for the name origin and found that comprehend has more meanings, like comprising or including by construction. The way I understand it is as follows. A comprehension is an expression that selects elements from a list and includes them in a new list. Until now, you have practiced comprehensions with lists, but comprehensions also work with dictionaries and sets. Dictionary comprehension. Look at these two lists. They look like the keys and values for a dictionary. For the Python programmer, it is clear that keys and values belong together. A comprehension can take the two lists and create a dictionary. Let me show you. Here are both lists. To create a dictionary from them, we need comprehensions, zipping, and unpacking. So a few techniques will be combined. Here they are. The first thing you need to know is that a dictionary comprehension is surrounded by curly braces. So what comes between them? K:\v returns a key-value pair. K and V are unpacked values. But from what? The source of the unpacking will be the two zipped lists. The lists are zipped and each tuple pair was converted to a key-value pair. Just like with list comprehensions, dictionary comprehensions can be filtered like this. As you see, the browser key is filtered out of the result. Time to practice dictionary comprehensions. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. It is also possible to create set comprehensions in Python. Here you see an example. You already learned that sets ignore duplicate values. This also applies when using comprehensions. Notice that the list contains the number 3 twice, and the result set contains the number 3 only once. So what about tuple comprehension? This is not possible in Python. Let me show you. That is interesting. V1 is not a tuple, but a generator object. A comprehension surrounded by parentheses is called a generator comprehension. So what is generator comprehension and when is it useful? The first thing to know is that generators are lazy. What does that mean? You have already worked with lazy objects in this course. The reverse iterator was a lazy object, and the zip function too. One of the key features of lazy objects is that they only generate elements on request. Look at this code. The x values and y values are lists that can be very long. The lists are zipped and iterated. But the zip object itself does not contain the full lists. When the for loop requests a new element from the zip object, it produces a tuple with the next x value and next y value from the lists. The zip object works as a cursor and is very memory efficient. A generator expression also behaves like this and has some very nice use cases. Let me show you the first one. Check if an element of one list is in another list. As you remember, this was very easy to do with sets. But to check if an element from one list is in another list, you have to combine a few things you have already learned. Let me show you. I'd like to know if at least one of the team members is also in the group of admins. For this, I can write a function. And that works. I bet you have already written code like this. Now let me show you how to combine generator comprehensions and the any function to achieve the same goal. The result is also true. What happened here? The teams list is looped here. Python checks if T is in admins. Notice that this is a generator. That means it produces a result only when requested. The any function requests new elements, and when the first true is returned, the any function returns true. After that, there is no need to search any further. This is very efficient since the list does not need to be iterated till the end. Something similar happened in the first example, where the function also returns when the first admin is found. But combining the any function and a generator expression is a very compact alternative. You can also check if all elements are in another list with the all function. Let's check if all the admins are also in the team. Very nice. I know that comprehensions take some time to get used to. Once you can read and write them, they will add extra powers to your coding skills. Time to practice. Generator comprehensions with any and all. Fill out the missing code. Pause the video and resume when you're done. And here is the solution. Let me show you a final example of what you can do with generator comprehensions. If you are familiar with other programming languages like C#, you probably know the concept of first or default. JavaScript developers know this function as find. What does it do? Look at this list of numbers. I'd like to find out which is the first number that is greater than 10. The first or default and find function can do this. But how can you do this in Python? I'll first create the generator comprehension to get all numbers greater than 10. The generator comprehension returned a generator object, which can be iterated. The numbers greater than 10 are printed. But the goal was to only get the first number greater than 10. Python's built-in next function can be used to request elements from the generator object, starting with the first one. The next function returned the first element. What happens if you request the next element? Just as expected. What happens if you request yet another next element? Boom! A stop iteration error occurred. That raises a question. What if the generator object cannot produce values at all? Let me delete this code. I'll change the predicate to all numbers greater than 20. The same error occurred. When the generator cannot produce elements, a default value needs to be returned. This can be done with a second argument for the next function. This time, the next function returned a default value when the generator could not produce elements. And what happens if I add a value greater than 20 to the list? Python returned the first number greater than 20. You just saw how to create a first or default function in Python by combining the next function and a generator comprehension. And with this last topic, you have finished the last chapter of this course, Comprehensions. You have come to the end of this course. Together we have made quite some journey. We've looked at the 4 container types: lists, tuples, dictionaries, and sets. You have learned how to use common operations that work on one or more of the built-in container types and used slicing and comprehensions to transform lists. I want to congratulate you for finishing the course. But your learning does not stop here. What can you do after the course? If you like the course, you can enroll in one of my other online courses. Go to pythonforeveryone.com to see a list of them. And of course, practice what you have learned in this course. I always recommend watching the course a second time and do all the exercises again. This will solidify what you have learned. I hope you enjoyed this course as much as I did creating it. I'm curious to hear your thoughts on it and how you will use what you have learned. You can share that in the course review, and if you want to discuss further, you are welcome to send me an email at this address. See you in the future.